Greetings, Math fans. Alright, so today what we're going to do is we're going to look at a lot of the graphs that we've created, and we're going to investigate something called a limit. Okay, so let's just start out here. It's called a limit of a function, and it says consider the function y equals f of x with an infinite number of ordered pairs in this function. Basically, you're going to look at x and y. Okay, x is going to change, y is going to change. Suppose you choose a collection of x values very close to a particular number. For instance, let the x values approach. This is a really key word, so I'm going to highlight this right there, math fans. Okay, today's lesson is all about approach. It's kind of like Dairy Queen. Okay, because Dairy Queen, you can approach Dairy Queen, you can get closer and closer to it, you get your face against the window, you've approached it, but you're not there. Okay, people who are there are actually inside ordering that ice cream, getting the ice cream. You are approaching it, so you're a millionth of a millimeter away. And that's what approach means. Okay, so you're letting x approach a certain number, which as we'll call it x equals c, and record the accompanying y values. So y values also get closer and closer. They also approach a certain number. We'll call this value L. All right, and we keep going here. The number L that y values are approaching as x values are approaching is referred to as the limit of y equals f of x as x approaches c. So this is what it looks like here. Okay, this is actually pretty important right here. That's called your limit. Limit, and it's read as the limit of f of x as x approaches. This little line means approaches c is L. So what I'm going to do is I'm going to give you values of x. I'm going to say, hey, x is getting closer and closer to some value, and then you're going to tell me what does f of x get close to, because f of x is your y value. Okay? So it needs to be noted that the x values in question can approach from either the left side, the right side, or from both sides. Okay? So we can left, right, or both sides. Approaching x equals c from the left side gives you this little negative here. I'm just going to kind of point that out. That little negative right there, that's approaching from the left side. Think of a number line. The left side of a number line is negative, right? And that may yield a different limit on the y value than if we approach x equals c from the right side. And notice this little plus here. That means the right side. Really important to recognize that. And it's the one after it. It's like the exponent after it. Okay, we call that the superscript after the c. If it's before it, then it's actually the number. Like -2 is -2. But if it's -2 from the little plus sign, that means it's from the positive side or from the right side. Okay? So in this nice little cloud formation here, we have limit as x approaches c from the negative side, which is again from the left side, and limit as x approaches c from the positive side, which is from the right side, are called one-sided limits. Okay, if there's no sign after this, notice there's nothing after, there's no plus sign or minus sign after that c, that's called a two-sided limit, which means we're investigating what's going on actually from both sides. So please, again, do not come up in the middle of a test and say, Mr. Curvis, is this coming from the right side or the left side? Because I'll tell you, go sit down. Okay, you should know that it's actually a two-sided limit and not a one-sided limit. So a couple important things here. If the limit as x approaches c from the negative side, which is the left-sided limit, is equal to limit as x approaches c from the positive side, which is the right-sided limit. So if those limits are equal, and they equal a value L, then we can say the two-sided limit, this is a two-sided limit, TSL. Okay, that means the two-sided limit also equals L. Okay, it's only if the one-sided limits are the same. Okay, and the same thing can be said if I investigate and I tell you, oh, look at the two-sided limit is equal to L, then you could automatically tell me that the one-sided limits are both equal to L. Okay, so if I give you the one-sided limits and they're equal, that's what the two-sided limit is. If I tell you this is what the two-sided limit is, you can tell me, oh, well, that's what the one-sided limit is. Okay, but they have to be equal. Okay? And then this last little part here says, note, if one-sided limits are not equal, okay, so if you're coming from the left side and you're coming from the right side and those numbers are different, then we say the two-sided limit does not exist. DNE. That's how we abbreviate it. Some of you may think of DNE as do not eat, okay, but it actually stands for does not exist. So again, if the one-sided limits are not equal, then the two-sided limit does not exist. It's an important thing for limits. Okay? All right, so let's take a look at some of the graphs now, math fans. Okay, we've done these graphs the past day, and basically what we're going to do is we're going to investigate what the graphs look like, and we're going to evaluate what the limits are. Okay? So it says the first one is absolute value of x minus 2. Okay, so I shrunk this a little bit so we can kind of fit everything in here and see more stuff here. Okay, so guys, f of 2 means I'm there. If I said f of 2, it means, hey, what's going on when x equals 2? What is going on with y? Well, you guys should kind of recognize that, remember, it's just looking for a point. So when x equals 2, y is 0, right? Look at the point, the one I just made red. You guys agree? Okay? So when x is 2, y is 0. This is what a limit means. Limit as x approaches 2 from the negative side. So I'm coming from the negative side here, which is here. I don't care what's going on when I'm far away. I'm approaching the value of x equals 2. So this is my x equals 2. I'm getting closer and closer to that value. Okay, I want to know what's y going to. Okay, and again, I don't care anything that's going on out here, out here, out here, out here, out here. I want to know what's going on when I'm really, 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 really close to x equals 2. And what is y approaching? Okay, as x approaches 2, what is y getting close to? Well, isn't it getting close to 0? Okay, from the negative side. What about from the positive side? Well, again, here's the pot. I'm coming closer and closer and closer. I don't care, and I don't care when I'm far away. I want to get closer and closer and closer. I'm a millionth of a millimeter away, and then you can tell me, oh, what am I getting close to? What is the y value I'm getting close to? I'm also getting close to 0. Okay, so because these are equal, and only because these are equal, you can tell me the two-sided limit is also equal to 0. If they were not equal, you would write D and E, does not exist. But they are equal. Okay? The last limit here is limit as x approaches 3. So it's a two-sided limit. So what you're going to do, you're going to investigate, hey, what's going on with when I get close to 3? Well, I kind of plotted this point for you right here already. But I want you guys to understand that I have no issue at all with this graph at 3. You know, here you kind of had to look, there was like a, you know, the vertex was at that one point. But if I come from the left side, so let me do this in a different color. If I come from the left side, again, I don't care what happens here, 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 here. I just care here, and I care here, right? I'm coming from the left side. What am I approaching? Well, I'm approaching 1, right? Because look at the value of y. The value of y is 1. And what about coming from the right side? Well, do you guys agree I'm also approaching 1? So the answer is 1. That's the two-sided limit. Okay? And obviously the one-sided limits were also the same. Okay? So again, you're looking at what happens when you get really, really close from one side or the other, and that is your one-sided limit, and then if they're both the same, that's your two-sided limit. And well, it would be whatever that value is. And if they're different, does not exist. Okay? All right, so let's look at the next one here. Move this down just a little bit. Okay, it's actually the same graph as number 1, except now there's a hole at 0, at the vertex, right? So what you're going to tell me is if I said, what's f of 0? Well, it's undefined. There's a hole there. All right, so if it's a hole, you can't define it. You can't tell me there's anything there, so it's undefined. Okay, now let's approach it from the negative side. Well, if I approach it from the negative side, I'm coming closer and closer and closer. I'm never actually getting to the hole. I'm getting a millionth of a millimeter away from that hole. So what's the value of y getting close to? It's getting close to 0. Okay, I'm never going to get there. And that's what you need to understand really early in this lesson, math fans, is that when you approach a hole, holes don't matter with limits. Because you're getting closer and closer to the hole, but you're never actually getting in the hole. It's like a manhole cover, right? You're going to walk closer and closer to the sewer hole, that hole there, okay? You're going to get really close to it, but you're never going to fall in because you're only approaching it. You want to see what's going on in that hole, all right? But if I said, hey, I want you to actually get on top of that hole, now you're saying f of that hole. You're getting actually on the hole, and then you're going to tell me, hey, what's going on at that hole? And in this case here, it was undefined. But as I get closer and closer to it, Okay, I'm getting closer to the value of y, which is 0. What about if I come from the other side? Well, I'm also getting closer and closer to 0. Okay, not getting to it, otherwise it would be undefined, which limits can never be, by the way. We'll talk about that in a little bit. Limits can only be does not exist or a value. F of some value is undefined or some value. Don't intermix the two. Limits can never be undefined, and f of some value cannot be d and e. Okay? Okay, so the one-sided limits are equal. So because the one-sided limits are equal, you can tell me that that is also equal to 0. Okay? Let's just look at another one. This is as x approaches 2. So that's where this blue dot is right here. I'll make it green now just so you identify it. So that's this dot right here. So what happens when x goes to 0? Well, let's investigate. Coming from this way, oh, the value is 2. Coming from this way, oh, the y, remember it's y values. What's the y value going to? Oh, they're both 2. So that the one-side limits are both 2. That means the two-side limit is 2. Okay? All right, let's take a look at another one here. Number 3. This is one where we canceled that x plus 3 out, remember that? And that created a hole. So if I said, what's f of negative 3? You're going to go to negative 3 and you're going to go, oh, there's a hole there. Okay, that's undefined. Okay, now let's approach it from the negative side. Okay, so if we approach it from the negative side, what's the y value getting close to? Well, that value is negative 6. What about from the right side? Oh, value is also negative 6. Okay, because again, I don't care about a hole with limits. Doesn't matter. Remember, getting to the hole. Okay, and then what happens, of course, because these are equal, we can say that it is negative 6. Okay, it's probably, the yax is probably in the way over there. Okay, it's equal to negative 6. And what about as x approaches 0? That's letter E. Well, do you guys agree? As x approaches 0, it's right here. And there's no issue at all. I don't even have a hole. I don't have to worry about anything. So if I come from the left side or the right side, the value of y is negative 3. So there we go, negative 3. Okay, not bad. I hope you guys are catching on to this a little bit. It's really not that bad. Okay, number 4. It's a piecewise function that we did. And what's f of 4? Remember, f of 4 means I'm there. I'm looking for a dot. Well, before it was undefined because there was just an open dot. But you guys see, like right here, I have a solid dot. So it is defined there. So if I actually say f of 4, that means that value is right there, and my answer would be 5, because that's what 5. 1, 2, 3, 4, 5, right? That's pretty easy. Okay, now let's approach it from the negative side. Well, again, I don't care what happens here, 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 here. I only care as you get really close. And what's the y value when I get really, really close? Well, it's negative 1, 2, 3, 4. It's negative 5. And what happens when I approach it from the other side? Well, I'm over here now. I'm approaching it. I don't care what happens here. I only care what happens when I get really close. And what's the y value there? It's positive 5. Okay, never actually getting to the point or the hole, but I'm approaching it. So they're both, one is negative 5, one's positive 5. Because these are not equal, this does not exist. The two-side limit, which again has no number or no sign after, right? Limit as x approaches 4, that does not exist. Okay? So it's really not bad. I mean, once you get used to the limits, they're really, really not bad. Okay, let's look at number 5, another piecewise function. But notice this function connects. So what's f of 2? Well, f of 2 means I am there. I'm at the point right here. And so what's the value of y? Negative 1, 2, 3, 4. So negative 4. Okay, let's approach it from the negative side. Okay, right there. Oh, well, I'm getting close. What's the value of y? Negative 4. What about from the other side? Getting close. Oh, negative 4. So because these are equal, that two-side limit is negative 4. What about f of, when limit is x approaches 3 of f of x? So 3, you kind of look and you're like, well, gee, Mr. Curvis, 3 is here. I don't even know what it is. Well, because I have no issue, it's solid line here, right? I don't have to worry about even investigating that much. I can literally just plug in 3 into one of those two piecewise functions. Well, you should recognize you should be plugging into the top one, because when it's greater than or equal to 2, that's what the function is. That's this, this line here, right? Let's get right here, right? That's that line. So you just plug it in, and if I plug in -3 times 3 is -9 plus 2 is -7. So that point would be -7, so it's approaching -7. Okay? Okay, let's keep going here. Number 6, okay, this is the one function that I told you, you will see this a ton. Absolute value of x over x. So when I said f of 0, well, f of 0, isn't it undefined in both of these places here? So that's what you're going to write, undefined. Okay, what about f of 2? So again, I'm at 2. What's y? Well, y is 1. I don't have to worry about a limit. I'm just worried about what's f of that value. I'm there. Okay, now I'm worried about a limit. So letter C here, x approaches 0 from the negative side. Well, let's look at it. Approaches 0 from the negative side. Again, I'm never getting to the hole. What's the value of y? It's -1. Well, let's come from the other side, from the positive side. Oh, it's +1. Okay, so we can fill those in. So this is -1 and +1. And what happens, again, these are not equal. So what can you tell me? DNE. Okay, not bad. So that's really what limits are all about. Limits are about approaching from the left side, right side, or two-side limits. Okay, so let's talk a little bit about endpoints, because that always kind of throws people off. If there's an endpoint to a graph, sometimes like in a piecewise function, or maybe just the function ends because it's like the square root of a number and it's not defined in a certain area. So let's investigate the one-side limits first. So if I ask you guys to the limit as x approaches -3 from the negative side, well, if I come from the negative side here, what's the function in this area? Well, it does not exist. It's not defined, guys, right? It's not even defined when x is less than -3. It's a void here, right? There's nothing here. So because the limit coming from the left side doesn't exist, well, let's investigate. What about the limit as x approaches -3 from the positive side? Well, that you can tell me because I'm approaching it from the positive side. What's the value of y? Well, isn't the y value -2? So because these are not the same, and not even because they're not the same, because that doesn't even exist, this two-side limit does not exist. Because in order to have a two-side limit, the one-side limits have to be the same, and if there is no one-side limit for one of them, does not even exist, you certainly can't have a two-sided limit. Okay, so that's important for that endpoint, and of course it's going to be the same thing for the right endpoint. You're going to approach 4 from the negative side. So, well, here's 4 from the negative side. What's the value of y? 3. What about from the positive side? Well, there's nothing here, right? It's a void. So this does not exist as well because it's not even a function. So this is DNE. So that means you could tell me the two-side limit also does not exist because one of the, like I said, the coming from the right side doesn't exist. Okay, so that's how we talk about endpoints. Again, this is this one does not exist because it's not defined when x is greater than 4. When it's equal to 4, still defined, but as soon as it's greater than 4, not defined. Okay? Alright, so this is all by investigating limits by looking at the graphs, and sometimes you're given a nasty little function. Let's take a look at this next problem here. It says it's y equals x cubed minus x squared minus 7x minus 2 over x plus 2. That's a nasty little function. And if I want to investigate what's going on with that function as x approaches, so here I have it here, as x approaches -2, basically I want to say, well, what happens when I get really close to -2? Now, again, with the graph, you just look at it. But when it's a function and you don't really have a graph yet, what you can do is you can actually plug in points that are really close to -2, because remember, that's what limits are all about. Limits are about approach. I want to get really, really close. I know when it's -2, I can even see if I plug a -2 into here, -2 plus 2 is 0. I know it's undefined. So I can actually write undefined here because I know it is. All right? But now I want to plug in values that are really super close to that -2. And we're going to use a nice little function on our calculator. It's called the table function. Okay, so let's take a look, because again, I want to investigate the one-side limits and then the two-side limits. So I can actually fill this in as well. This is undefined. F of negative 2 is undefined. But I don't know anything about the other stuff because what's it approaching? So let's pull up your TI here, math fans. And let's type in this function. And you got to be a little careful typing in the function because you got to have a lot of parentheses here. So hit your y equals and make sure all the ones are cleared out. So I've had some kids kind of say that he's giving me an error. Go down to y equals, all the way down to y equals 0. Make sure it's all cleared out. If you have a decimal or a little line, it's going to mess up your graph. Okay? So let's go back up. Once you have that cleared out, let's go back up to the top here. Oops, y1. Okay. So I'm going to type this function in. I'm going to put a parenthesis on the top because it needs a parenthesis. And I'm going to say x cubed. Make sure you cursor over, otherwise it'll stay on top of the exponent. Okay, minus x squared minus 7x minus 2, close the parenthesis, divided by, you need another set of parentheses, really super important, and then x plus 2, close the parenthesis. Okay, and then what you want to do is you want to hit zoom 6. Zoom 6 actually is a really nice zoom. It kind of brings everything in, you know, depending on what the graph looks like, but it brings it into your screen. So you can see it. Hit zoom 6. And there's my nice graph. Okay, it's a parabola. It's very interesting. Okay, we have a cubic and it's a parabola. Okay, so that's cool. And so now what I want to do is I want to use the table function. And the table function, if you guys hit second window, so this button right here where my little cursor is pointing, second window, this is what you come up with. And this is your table setup, that's what I'm doing here. You need to have your independent and dependent variables. One has to be ask and one has to be auto. Okay, the first one needs to be ask, second auto. Once you set this, it really doesn't change unless you come back and actually change this. But we have ask and auto. Okay, so now what we're going to do is you're going to hit second, and you're going to go with this top right button. It's the second graph button, which if you see in blue, it says table. So this is our table, and you may have values in here, so you can we're going to just type over these values here. But I'm going to type in, and if, so again, it doesn't matter what you have in there. But if I type in negative, so I'm going to look at my numbers here, and I'm typing in negative 2.1. So negative 2.1, hit enter. Negative 2.01, hit enter. Negative 2.001, enter. Negative 2.0001, and look what that's going to turn into. If I type that in, it still says negative 2. And let me type in one more. Let me type in the one we actually got undefined here. So I type in negative 2. Okay, so these are the first 5 values I just typed in here. And notice it, after I typed in negative 2.001, it just went to negative 2. It's just because it's rounding. It can only fit 3 decimal places in here, and so it's just rounding. So if I type in these values, you look what the y values give you, okay, which is basically saying, hey, I'm giving you x value. These are what y values are. So I'm going to write these in. Your calculator is going to disappear off my screen, but you get 9.7100, 9.0701, 9.0070, and 9.0007. Okay? So let's bring up our calculator again. And notice when I typed in negative 2, it gave me an error, which it should, because there is an error if I actually type in the value of negative 2, it's undefined there, right? Okay? So let's do the other side. Let me move this calculator over here just a little bit. And I'm just going to go back over, I guess, so I got to cursor back up again. Because you can only fit 7 values, sadly, right? I have 5 values. I can only fit 7 values total, so I need to kind of write over some of this stuff. That's just, the table only handles 7 values. So let's investigate, let's just type in the way the order is here. So negative 1.9999, enter, negative 1.999, enter, negative 1.99, enter, and negative 1.9. Okay, so we can see we have, we're approaching from, let me just write these in again. Okay, so this is going to be 8.9993, and this is 8.9930, and this is 8.9301, and this is 8.3100. Okay, so you can see what's going on here, math fans. You're at negative 1.9, which is close, and negative 1.99, which is even closer, and then negative 1.999, and then 9999, right? You're getting closer and closer, and you can see it's 8.3, 8.93, 8.9930, 8.9993. We're getting closer and closer to 9. So if I approach it from this side, I'm approaching 9, and if I'm approaching from this side, I'm approaching 9. So let me write these in. From the negative side is 9. From the positive side is 9. That means the two-side limit is 9. So I know a lot of you might say the limit, and you might look at it just without even doing anything and go, gee, it's undefined there. But again, I don't know what's going on. I know f of negative 2 is undefined, but what's going on with the limit? That's why you plug values in and you investigate it to see what you got, and it actually turned out that it was a value of 9. Okay? So that's pretty much a scoop for using your calculator to investigate. And again, you plug it in, make a graph, and then you just type in different values. Okay. The one last thing I want to mention here, which I know I talked about this already, is DNE does not exist, and this is important. It's only for limits. Okay. Please do not use this for f of some value. And undefined, so UND or undefined, okay, is only for f of x. Okay, you'll never say f of x does not exist, just like you'll never say limits are undefined. Only DNE for limits and only undefined for f of x. Okay? Well, that's it, math fans. Hope you guys picked up here on what one-side limits and two-side limits are all about. And being an f of something meaning you're there. Okay? Have an outstanding day, math fans. Adios. Bye-bye.